Okay, so with this functional group and each one of these, they're just replacing the hydrogen. So it's basically kind of like stealing the electron that the hydrogen had accepted, and you're replacing it with something. All right. Again, all these notes are always online, so you can look at them. But and this is that idea of the R structure. So the takeaway from this would be the R is just like an X in math class. It just represents a bigger structure. Okay, the R could be 1 carbon, it could be 1,000 carbons. All right, and it will basically. One of the reasons why we use hydrocarbons for like fuel is they're super non-reactive. And you're like, wait a minute, I thought you just said we use them for fuel. We do, but if they weren't pretty stable, every time you lit your barbecue grill with your propane tank, it would just not only just light, it would explode, right? So it's not like they're just the most reactive thing ever. They're reactive when we want them to be. So, something like octane or hexane or methane, ethane, yes, they'll burn, but they don't they're not crazy reactive. Does that kind of make sense? Do you understand? Like, they're pretty stable. So what chemists do a lot of times, and this happens naturally too, is they'll add a more reactive substance to it to functionally change it. And this is how we get things like pesticides, okay? And how we get things that are cleaners and solvents, all right? We take hydrocarbons and we add more like reactive substances to them to make, I guess, more reactive. Okay. All right. So again, these are all the ones that you could know, but I'm not going to make you know all those. We're just going to know a few. So here's the first one, the alkyls. If you would, just take and take 3 black balls and put them together. Okay. And then put as many of the hydrogens on there as you can. Okay. So you're going to have something that looks like this. Now, after I form this one with all these hydrogens, if it's okay with you guys, I'm not going to put the hydrogens on them anymore because it just takes too long. I wouldn't be able to show you all the different ones that we're going to walk through if I did this for every single one of them. Oops, that stick's broke. Okay, so we have the chemical compound propane here. Okay, right? So it's C3H8, and it looks like that structurally. Okay? We have 8 opportunities to functionally change this compound. And we've actually already done it once. Twice. Remember with alkenes and alkynes, what we did? Didn't we steal hydrogens, right? And we formed like double bonds between them, like this. That's an alkene. That's a functional group. Or we formed triple bonds, right? Okay, so that idea of like replacing or pulling off hydrogens shouldn't be that new for us because we've done it before. So one of the things you can do is instead of having a hydrogen here, you can actually replace it with a carbon. And if it's a little carbon or a smaller hydrocarbon, like a methane, what we do is we call it an alkyl. And instead of calling it methane, we call it methyl. Okay? So right now we've created a longer chain, these three here, with a smaller hydrocarbon on it. That's what an alkyl is. Does that make sense? It's a smaller hydrocarbon on a larger hydrocarbon. Okay, so it's an alkane on a small alkane on a larger alkane. So this becomes this, which means we've added hydrogens and carbons. Okay? Does that confuse anybody by doing that? Now, we could actually do it one more time. You can only put, I won't put the 3 around here, but pretend there's 3 around here. Okay? You can only put alkyls in the middle of an alkane. All right? Because if I did this, watch what I do here, guys. If I take this one off and I put it over here, all I did was just make butane. I went from propane to butane. So that's not what I want to do. There's that. Okay? So this would be this. And it changes it to C5H12. Got it? So that's our alkyls. All right? They're just small, smaller hydrocarbons attached to larger ones. Smaller alkanes attached to larger ones. Okay? And the way we name them are like methane becomes methyl, ethane becomes ethyl, propane becomes propyl, and butane becomes butyl. And you can go into pentyl and all those. Probably the longest that we'll get to is propyl, and that will be pretty rare. I think you have to have 6, a chain of 6 in order for it to work. Okay, you can't have anything shorter, and I'll explain that when we go over the project here in just a few minutes. All right. Haloalkanes. I think these are pretty simple. All you got to do in a haloalkane is just replace one of the hydrogens with a halogen. And if you don't remember the halogens, that's group 17, iodine, chlorine, bromine. Okay, do you remember those? And fluorine. Super reactive atoms. They are the most reactive nonmetals that we have. And so that's why a lot of times they'll put these on to form reactive substances, because the hydrocarbon themselves, they don't do a whole lot. Okay, they're almost like, if you want to think of it this way, they're kind of like shuttlers or taxi cabs delivering something that is reactive. Okay, so in this case, we've got a chlorine that's attached to an ethane. So that's why it's called chloroethane. So chlorine turns into chloro, bromine turns into bromo, iodine turns into iodo, okay, which is kind of a funny one to say. And then, let's see, bromo, chlorine, and then fluorine turns into fluoro. All right, those are the ones right here. Those are your halides. They're called alkyl halides, but I always usually just call them haloalkanes. But you'll also see them called alkyl halides. And the general formula is a resident structure is an R, and then they'll put an X, and the X can be any halogen: iodine, bromine, fluorine, chlorine. Okay? Does that make sense? So we can make some here. So let's go back to our base propane here, right? And then the orange and the green, we can just call them, let's call this one iodine, all right? Okay, so we're going to put an iodine in for where that hydrogen was, okay? And let's put, I don't know, let's use this kind of purplish one. We'll say that that's bromine, okay? Now, I put them in the middle. Alkenes had to be on the middle, right? These don't. These can go anywhere. So what I've got here is I still have propane like that. And if you guys will remember, what's at the end right here? Like what is, it's not drawn or what's right there? It's a carbon. And there's a carbon there and there's a carbon there, right? So if I draw a line and I actually write out a symbol on there, that line doesn't mean that there's a carbon on it when I do that. Or if I do that. Do you understand? Like there's no carbon right here or right here. That's just showing the bond. Okay. So the name of this thing would still be propane, but we need to signify that on the second and on the second carbon, some stuff's going on. There's, you just do it alphabetically, bromo, chloro, propane. Sorry, I ran out of room there. Does that make sense? You could move these wherever you wanted to and say, I want to put this one on the first one. And again, I just picked fluorine and chlorine. I could put these like that. Well, then this would be one, and I think the orange was fluorine. One it would be two bromo, one fluoro propane. The number just tells you where the functional group is. Got it? Questions on haloalkanes, on halogens? Pretty simple one. Okay, I will show you one that's kind of cool because it kind of changed, society. Yeah. It allowed us to have big casinos in deserts, and it changed the suburbs totally. They're called CFCs. You ever heard of them? Well, maybe I can show it right here. Can you guys see? I don't know if you can see it. What that says? It's not going to zoom in enough for me. Right there. It says no CFCs. CFCs are chlorofluorocarbons. And when they first came out, they were game changers. I mean, literally, it's Freon. And when I was a kid, like a little kid, I had my .22 rifle. It was pretty awesome to shoot a can of Freon because it was like a rocket. They're highly pressurized and they wouldn't explode, but they would go because they're pressure. You could shoot them 50, 60 feet up in the air. They would go off. Problem was I was releasing CFCs in the atmosphere. Okay. But my dad had them because you could put them in like your refrigerator. You could put them in your car. It just took a hose and just stuck it on there. Now you have to be certified to do it because they realize that CFCs, they don't go away. They stay in the environment. All right. They're too good at what they do. And if you know anything about CFCs, they destroy ozone. Okay. We had this gigantic problem with the hole in the ozone. We actually fixed it. It's good for us, good for humans. We had a problem where ozone blocks UV radiation, which causes cancer and cataracts and autoimmune disorders, all kinds of stuff, Well, when we banned this in 78, 79 or whatever, it took a while, but because we don't have CFCs and they look like this, they're pretty, the simplest one would look something, one of these, that, like that. If these are chlorines and these are fluorines, it's just a haloalkane. It's a methane with all the H's replaced with chlorines and fluorines. super stable, doesn't cause cancer, doesn't like ignite, doesn't cause problems to the environment at the trophic level that we live, like the troposphere. But when it raises up in the atmosphere and it comes in contact with UV radiation, these guys split off. Okay, and what they do is they come in contact with this guy, which is doing a great job in the stratosphere 9 miles up of blocking UV light. Okay, ozone, O3. But what they do is they come along and they knock out and they destroy the ozone. Okay, and like one of these atoms can destroy several molecules of ozone. So we banned it. So yay for us. We did a good thing. Okay. All right. So that's the halos. Okay. All right. So then finally, and I hope I clicked on the right thing. This is all presenting. The last one we'll talk about. Take 2 carbons and put them together. You want to shut that? Could get loud. And then take a red one and a white one and put them together. And you'll notice from the notes that alcohols, they're named by taking whatever the hydrocarbon is and just ending it with OL. I know you've heard of this. Ethanol, methanol, propanol maybe, like isopropyl alcohol. You ever heard of that before? Like rubbing alcohol? Yeah. These are just hydrocarbons with what's called a hydroxyl group added to it. That's an OH group. So what I want to show you here, did you guys put this together for me? What's 2 carbons put together? What do we call it? What's 2 carbons? 2, when you're talking about hydrocarbons. What's the prefix? It's not meth. What's 2? Nobody remembers? Like this? F, right? So this is ethanol. Has everybody got this in their hands right now? Everybody make this? Shame on you. You have vodka in your hands. You have whiskey in your hands. You have beer in your hands. Okay? This is alcohol. This is like the alcohol that people drink, okay, in beer or whatever. Okay, it's the same. It doesn't matter it's fermented fruit, grains, rice, whatever. Okay, yeast produce ethanol. Okay, ethanol has a hydroxyl group attached to it. That's this thing here. Okay, prohibition. You guys studied that, right? Okay. The problem with prohibition is this: people wanted to still get their drink on. Okay, so what they did was they started making their own alcohol. If you don't distill it correctly and you don't burn off at the right temperature, you make this. And this is called methanol. Methanol is just 1 carbon different. That's it. It's just a C with an OH and 3 H's. You would think, it can't be that big a deal. You still get drunk off of it, but you go blind. And you can die from it. It's poisonous. All right. There's an old saying that it was blind, stinking drunk. Yeah. People were making this, and they in their bathtubs, they're making like vodka and gin in their bathtubs, and they're boiling it off. And as a result, they were actually making methanol as well. This even happened not too long ago with this stuff, hand sanitizer. This is ethanol. says it right here. Active ingredient, ethyl alcohol. Ethyl alcohol is ethanol. What they did was that when they manufactured these really, really cheap and they wasn't being regulated, they were putting methanol in here and it was poisoning people and hand sanitizers just within the last few months. So that is alcohols. The way that you name this, if it's like multiple, form like four, put four together. Don't worry about the little white balls if you don't have them on there. Just put four carbons together. And I'm going to take them off because it lays easier. All right, so what we have here looks like this, right? 1, 2, 3, 4. 4 is butane, all. This just so happens to be, I'm going to flip it around so it's a little easier to see. Just so happens to be on the first one, so it's 1 butanol. If we move it and put it to here, it would be 2 butanol. Again, the number just tells you where the functional group is. Does that make sense? All right. So that's pretty much it for the functional groups that we're going to go over today. Okay. So then the next thing we're going to do is I'm going to show you the project. Okay. So let me stop this.